Now let's go over LeetCode question number 734, sentence similarity. We can represent a sentence as an array of words. For example, sentence I'm happy with LeetCode can be represented as an array with all the characters, all the words in an array. Given two sentences, so we're going to be given two sentences, sentence 1 and sentence 2, each represented as a string array, and given an array of string pairs, similar pairs, where similar pairs at index I is given two words, indicates that two words x at index I and y at index I are similar. So we're going to be given two arrays. One is sentence 1, sentence 2, and an array of similar pairs where we have two words in each array. Okay, so what is similar pair? Return true if sentence 1 and sentence 2 are similar, or false if they are not similar. So what is the definition of similar? Well, it says it over here. Two sentences are similar if they have the same length, so they have to have the same number of words. So this is condition 1. Sentence at index I and sentence at index I are similar. So that means that they are the same, right? The numbers or the characters or the words itself are the same. So that's condition 2. Notice that a word is always similar to itself. So if you have the same word, it's obviously similar. Also notice that similarity relation is not transitive. Well, for example, if a word A and B are similar and the words B and C are similar, A and C are not necessarily similar. So A is similar to B and B is similar to C, but that doesn't mean A is similar to C. So it doesn't mean that. Now let's look at our example. We have sentence 1, we have our array of words. Sentence 2, our array of words. Now we are given our similar pairs, so we have to look at our similar pairs and compare the two words. So in the first iteration, we're going to be looking at great, fine, and this first pair. Well, is this similar? Well, we have great in our sentence 1, we have great in our first pair, we have fine in our sentence 2, we have fine in our pairs. So the first pass is good. So it's true for the first pair. Next one is acting and drama. Well, we have drama and acting, so it's another pass. And do notice that order may be mixed up. So in the beginning, we had great and fine. We have great and fine, but for the second one, we have acting and drama. But here, drama came first and acting came later. So the order doesn't matter. And last one is skills and talent. And we have skills and talent. So all of them passed our test. So we can say that our sentences are similar. So we return true. Now let's look at example 2. And example 2 is our second condition where sentence 1 at index I and sentence 2 at index R are similar. So we have great and great, and great and great, they're obviously the same thing. So return true. So we don't need a pair that says great and great. If the words itself are similar, we can just return true. So that's our, again, condition 2. Third one is we have sentence 1, just one word. Sentence 2 has two words. And remember that they have to have the same length. So this fails that first condition. So we return false. Now, given this, try to implement your own solution. So remember the three conditions. First one is that it has to have the same length. Second one is if the words are similar, we can return true. And if we are given a pair like this and bunch of words, try to look for a pair that has both of the words. But remember that the order doesn't matter. So as long as it has all the pairs of words, so great and fine, acting and drama, and skills and talent, it's going to be defined as similar. So try to implement your solution and come back to the video if you need help. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's implement our first solution, and our first solution is going to have a time complexity of O of n squared and space of O of 1. Now remember our three conditions. First one was that they have to have a same length. So our sentences has to have a same length. So if you were to look at sentence 1 and 2, it has a different length. So that immediately makes our sentence not similar. And second condition was that If the words are the same, it's considered similar. So it doesn't matter if we don't have a pair. As long as the words are the same, it's defined similar. And now is our last condition. And last condition was that if the words at the same index are in any of the pairs, it's considered similar. And the order does not matter, right? So great can come first or fine can come first. It doesn't matter as long as they're in an pair of array. Now, the idea for this question is, well, we know that as long as all the words pass the test, it's similar, right? If any one of them doesn't pass, it's not similar. So what we're going to do is we're going to keep a count of how many elements pass the test. And if that count is the same as the length of our sentence 1 or sentence 2, we're going to return true. If not, we're going to return false. So given that, let's try to implement our solution. Now, first, let's take care of our first condition where if the length of our sentences are different, it's going to fail. So it's going to return false. If the length of sentence 1, if it does not equal to length of sentence 2, we want to return false. Okay, that looks good. And I'm going to make a count variable to keep count of how many elements or pairs of numbers that pass the test. And now let's iterate through our sentences. So let's create our for loop. And let's create two variables, w1 for the current word for sentence 1 and w2 for sentence 2. All right, that looks good. And now we have to be able to iterate through our pairs. So let's create another for loop, and let's actually create another variable pair for our current pair so it's easier to read. Okay, now we have to be able to handle our other cases. And the first one was what? It's when the words are equal to each other. So let's handle that. So if current word at sentence 1 and sentence 2 is equal to each other, we want to increment our count by 1. And after we do that, we want to break, because there is no point of keep looping through the rest of the pairs. If the words are the same, we want to just return. And now is our other case, and this is when we want to handle if our current words are in our current pair. That's going to be if pair includes. So if it includes our word 1 and if the pair includes our word 2, we want to increment our count by 1. And also we want to break, because it might be the case that we have an array with two of the same words, but the order might be mixed up. So that's why we want to break. And there is actually no point of iterating further, because when we found our pair of numbers, we can just stop our loop and then check for the next pair. This way we save some time. Okay, that looks good. And finally, let's check if our count is equal to the length of our sentence. So down here, we do if count is equal to sentence 1.length, we return true, otherwise we return false. And this shouldn't actually work for one of our conditions. So let's check our results first. Here you can see that return false for this one, it's looking good, and return true for this one, but this one returned false. And why is that? Well, the reason is because, well, the words are the same, right? But we have an empty similar pairs array. So let's go back to our code. So here you can see that, well, we are handling to check if our words are the same in our inner loop. And this will work if we had bunch of other words and pairs in our similar pairs. But for our second example, this isn't going to work. Well, why is that? Why is that the reason? Well, because, well, our similar pairs array is empty, so it's actually never going to run this code. So how can we handle that situation? Well, we can actually handle it just up here. So we just do a check. So if sentence 1 dot join, if this is equal to sentence 2 dot join, we're going to return true. What this line will do is, if we have a bunch of words that are the same but have a empty similar pair, is going to concatenate all the strings and check if it's equal to each other. If it is, it's going to return true. If not, it's going to simply return false. If it's not, obviously this code is not going to run. So we just skip over it and just run our loop. So if you were to go down and check, you can see that this is returning true now. So actually that's it for our solution, and let's go over our code. The first line checks our first condition, where if the length of our sentences are different, that means that it's going to be not similar, so we return false. Next one is kind of checking the half of our second condition, where if the words are the same, we want to return true, right? And if you remember, why do we have to run this line when we have this line? And the reason was, well, if it is a case that our similar pairs was empty, but our words are the same, well, this loop isn't actually going to run because similar pairs has a length of 0. So if that's the case, this line is going to handle that edge case where the pairs array is empty. Otherwise, our loop is going to take care of the rest. Now we create our counts variable to keep a track of how many words pass the test. And if it does pass the test, it's going to increment our count by 1 each time. So after that, we iterate through our words. And when we have two sets of words from sentence 1 and sentence 2, we want to iterate through our pairs. Now we check, well, this is our condition 2, right? If word 1 and word 2 is equal to each other, we want to increment our count and we want to break. And why do we have to break? Well, first of all, we can actually save some time, because when we find our pair of words, we can just simply increment it and go on to the next pair of words. And another reason is because we want to avoid duplicates, because we might have an array of the same words in our pair. So if our words were great and great, you might have a pair of words that had great and great. So if this is a case, that would be a duplicate count, right? So we want to avoid that, so we break. And next we check, well, does the current pair include our word 1 and word 2? If it is, we want to again increment our count and break again. And why do we have to break again? Well, it's again to save time and avoid possible duplicates. So if it was a case that our words were, let's say, hi and bye, and we had two pairs that had hi and bye, but bye and hi, obviously this would evaluate the truth for both and would end up incrementing our count by 1 each time, right? And we don't want that to happen because this is a duplicate count. So we break when we find the first instance. And we do that for all the words in our sentences. And finally, we check, well, is our count equal to the length of our sentence? And you can actually replace this with sentence 2. It doesn't matter. If it is, we're going to return true. If not, we're going to return false. Now let's go over our second solution. And our second solution is going to have a time and space complexity of O of n. So for better time, we sacrifice our space compared to the first solution. Now, unlike first solution where we kept a count of words that are similar, and later we compare that count with the length of our sentence. But this one, what we're going to do is we're going to keep a map of all possible pairs into a map, obviously, and then check for each and individual word if the words satisfy our condition. And if all the words satisfy our condition, we're going to return true. If not, we'll just simply return false. Now let's try to satisfy our first condition. And our first condition is that the sentence has to have a same length. So same as before, let's check the length of our sentences. So if the length does not equal to each other, we want to return false. Okay, that looks good. And now we want to create a map of our pairs. So let's create our map and let's iterate through our pairs. Let's use our for of loop, and I'm going to destructure my array. So we're going to have word 1 and word 2. Now we want to check if our words are in our map. If it's not, we're going to initialize it, and we're going to initialize it with an empty array. So we're going to check if word 1 and word 2 is in our array. If it's not, that means that we never added that word to our map. So we're going to add the word along with the empty array to store a list of possible pairs. So if our word 1 does not exist in our map, we want to add it to our map and set it equal to an empty array. And then we want the same thing if our word 2 does not exist in our map. we want to add it to our map object. Now, if we were to console log our map, you can see that we have our words along with an array. And we're going to put the other pair into our array here. So let's handle that now. We're going to add at word1. We're going to push our word2. Let's copy this and then add the other case. So if you were to look at our map, you can see that we have all possible pairs of our pairs array. And right now, all the pairs only have one word, but if it was a case that we had more, so something like, let's say we had a pair that had great and buy. Well, our great key would have find and buy, and we would obviously add one more key and it would be buy, and it would have an array with the word great. So here we have all possible pairs for our similar pairs array. So after that, what we have to do is now we have to do our checks. Well, we handled our first check where if the length is different, we want to return false. So now we want to handle the two other cases. Now to do that, what I'm going to do is I'm going to use a method, the every method. So return sentence 1, and we're going to use every method on that array, and it's going to take two arguments. First one is the word and second one is the index. Now let's handle our second condition. Our second condition was that if the words are the same, it's similar, right? So let's handle that. So word is currently our first word at sentence 1, so that's great. And then next is going to be acting skills. So if this is similar to our word at sentence at the same index, we can say that it satisfies the second condition, right? So this is our second condition. And next we have to handle our last condition. So if the two words are in a pairs array, it satisfies that condition. So let's handle that. So in order for us to do that, we have to first check if the word actually exists in our map. Because if it doesn't, we can't retrieve that word or that key from our map, right? So first we're gonna check if that word exists. So map, and we're going to get our current word and check if it's in there. If not, obviously this would fail. And if the word exists in our map, and we have to check the array with all possible pairs. So if the word exists, we want to look at this array and check if our word 2, which is sentence 2 at index I, exists. So to do that, let's use includes. So map at word. So if the array includes our word, so sentence 2 at index I, we can say that the words are similar again. So now we are actually done, and this is we expect true, and now you can see that it's returning our solution. So for the first one is true, and for the next two is returning true for this one and false for this one. So you can see that this is working well. Let's get rid of this line and let's go over our code one more time. Well, now the first line is handling our first condition where the length of our sentences are different. It's going to be not similar. So we return false. Next, we created a map of all possible pairs from our similar pairs array, and we added that to our map object. And each key or each word is going to store its possible pairs into an array. So that's what we did. And next we used every method on our sentence 1, and you can do it on sentence 2, it doesn't matter. And for each word, we check, well, this is our second condition. Is it equal to each other? If it's equal to each other, that means that it's satisfied our second condition. And our third condition is satisfied by this line. First, we have to check if the word actually exists in our map, because if it doesn't, it's going to return undefined. And if that word exists, we check, well, does it include the other word? So is it a legitimate pair that satisfy our condition 3? If it is, we're going to return true. If all possible words satisfy the condition given, if any one of them fails, it's going to return false, and it's only going to return true if all of them passes. So this is it for our second solution. If you guys find this helpful, make sure you guys like and subscribe. Thanks.